Students. So, welcome for one more session of chemistry. So, dear student, in the last class we have discussed about the line spectrum of hydrogen, right? So, this line spectrum of hydrogen is totally depend on what is nothing but I have explained about 3 points, right? Today we will expand this line spectrum of hydrogen. Already we know how the line spectrum of hydrogen or line will be produced in case of hydrogen. So, dear student, in this concept, what we did is, so there was a H2 with us, right? First of all, by applying a high, it is a gas actually, right? So by applying more, a high electricity, what we did is we have separated the hydrogen as a hydrogen gas as a hydrogen atoms like this, right? Why? Because when we cannot examine by taking gas simply, it will be very critical process. So that's why what we are doing in the first point, what we are doing is we have a hydrogen gas with us and we want to separate the H atoms, right? And this can we do by what? By applying high electricity, right? A very high electricity, then two hydrogen atoms will be separated. And remember, in the next point, what happens once if we got a hydrogen atom, then take that hydrogen atom into the consideration, and already we are applying a high amount of electricity, and the electron present in this hydrogen will absorb that energy, right? That means electricity or electrical energy. And then what happens whenever absorption takes place or else external energy if we apply, then definitely the electron try to absorb it. If it absorbs, then what happens? It will start jumping from what lower level to the higher level. So it is the actual level of electron of hydrogen. But what we are doing, because we have applied some amount of energy, so that's why our electron is somewhere, it came somewhere over here, right? So in the first case, what was happening? There was absorption or else gain of energy or else absorption, you can say absorption, right? So now what happens is in the next case, right? So electron will not stay here. Why? Because in the last class only I have explained excited state is what? Unstable state. So that's why it will not stay for longer in this excited state. Now it must and should come back to its what? Ground state. So while coming back from higher energy to lower energy, then loss of energy takes place. Loss of energy, right? So emission, one we can say, this process is called completely emission. Emission of energy is nothing but loss of energy, and loss of energy leads to what? The loss of energy leads to formation of color. But in case of hydrogen, what we observe is when it loses the energy while coming back from higher energy to the lower energy level, it forms a line spectra of lines. So that's why the name of this concept is line spectrum of hydrogen. And later the different scientists came in existence to explain about the hydrogen spectra, right? And for that, in book also you will be having the diagram what I will show now, right? So the different energy, see, the different scientists observe different energy levels and their explanation was also different, right? N is equal to fourth level, N is equal to third level, N is equal to second level, finally N is equal to first level. So these are the, see here, because we are getting the line spectrums, so in the hydrogen, so that's why these are the different energy levels. This is the first energy level, second energy level, third energy, fourth, fifth, and sixth energy levels. These are the energy levels, right? So according to them, right? So there are five different series with respect to this. So I will explain their names also, right? So one of these scientists called Lehman, and Lehman, what he suggested is, see, the electron may jump. This is, you imagine this is the ground state of that hydrogen electron, right? So now what we are doing, we are supplying electron is somewhere over here. Just imagine, right? So now what we are doing, we are applying electricity. Because we have applied electricity, that means it will jump to what? Higher energy level, right? So that's why according to the Lehman, the ground state of the electron is first energy level. And what he said, electron might jump from here, that means ground state. According to him, the ground state is first level. And what he suggested is, the electron may come to second level and then it might come back like this, or else it may jump from here to here and then come back like this, or else it will jump here. It is his imagination, right? Don't get confused. It is his imagination that the electron ground state is this, and what I said, the excited state level is depend on totally electron, that means absorption of energy by the electron. If it has absorbed more energy, then it might go to up to the last excited state, that is sixth level. So this is called a Lehman series, right? So according to Lehman, the ground state of any electron, electron present in the hydrogen is N is equal to first level, and it will jump from second level, third level. It might go for the fourth level, or for the fifth, or else for the sixth level. Next, one more series, that is Balmer series. According to Balmer, what he said is, the ground state of hydrogen electron is second cell. So that's why from second cell it will jump to third, it will jump to fourth, or else fifth energy level, or sixth energy level. And this is called Balmer series. According to Balmer, the ground state of hydrogen electron is second level. So just the ground state is different, right? And the ground state energy of electron of hydrogen is this much. So that's why electron might jump from here to third energy level, from second level to fourth, from second level to fifth, or else from second level to sixth energy level. And such condition, that means the energy what is the difference between Balmer and the Lehman is nothing but the ground state energy is more, right? Balmer says the ground state energy of hydrogen is not N1, it is N2, right? And now next, one more scientist came. What he suggested is, the ground state of hydrogen is N3, not N2. He has rejected him. That means the ground state energy of electron is this much. That's why the electron jump from N3 to N4, or else N3 to N5, or else N3 to N6. These are the possible energy absorption capacity of hydrogen electron. And his name was what? Paschen series. Paschen. So just see the spelling, Paschen series. According to Paschen, the ground state energy level of hydrogen electron is third level, not second or first, right? He has completely rejected the Lehman as well as Balmer. And one more scientist came. What he suggested is, the ground state energy of what? Electron is fourth level, or else n is equal to fourth is the ground state of what? Electron of hydrogen, right? So, and whose name is Brackett series. Brackett, and n is equal to fourth level is Brackett series, and these are very important, right? So you will be having a minimum one question on this diagram in your NEET, JEE, IEEE, or else KCET, right, Karnataka CET, whatever it may be, the competitive exam. They will just ask you what is the ground state energy of Brackett series, that is n is equal to 4, and what is the ground state energy of Lyman series n1, right? Like this you remember. And finally one more scientist came, and what he suggested is the minimum energy is n fifth level of hydrogen, and it might jump n fifth level to n sixth level, and whose name is P Fund, and the complete name is P Fund series. So these are the different scientists, so you don't be confused. So the different scientists came for the explanation of line spectrum of hydrogen, and their views are different. That means the energy levels are different in their different scientists. That means Lyman says the electron of ground state energy of electron present in the hydrogen is having very less energy, that is n1. That's why he had jumped the electron of hydrogen from n1 to n2, n1 to n3, n1 to n4, n1 to n5, as well as n1 to n6. That means this part, that means jumping part is no doubt, but the ground state energy level were different from scientist to scientist. Then later Balmer came, no, that means the energy state of electron present in the hydrogen is not n1, it is n2. Again, this is what debate one we can say, and they have given different views. And now I will give one chart on this, and later you can come to know in which state, that means in Lyman series will come in which spectral region. We will just see this, right? So you go through it. If you are having any doubts, please do ask, right? I will give one chart, and this chart is also very important. Why? Because indirectly they can ask, Lyman series will be having a region, spectral, what is the spectral region of Lyman series? Like this, they can ask. Series, that means N1 low energy state and N2 high energy state. That means, and next is the spectral region. So it is lower energy state, and it is higher energy state, one we can say, right? So series is, first one is, already we know, Lyman series. So according to Lyman, the least lower energy was number 1, right? N is equal to 1, right? And number 2, N2, that means higher energy will be that electron. The electron of hydrogen is having lower energy state of 1, but it will be jump from 1 to 2, 3, 4 and 5, like this. That means the higher energy levels are 2, 3, 4, and 6. 5, and 6, like this. But the lower energy of hydrogen electron is 1. Already we saw, right? And the spectral region is ultraviolet, UV, you can say. The reason is, according to him, the reason of that spectral region is UV, ultraviolet one we can say. Next, Balmer means what he said. That means according to Balmer, the lower energy state was 2, right? Already we saw. And from 2 to, it might jump 3, 4, 5 and 6. And whose spectral region is, right, visible region. Directly they will ask, right? Next, bomber to next passion, right? Bomber to passion. So according to passion, the lower energy was third energy level, and what he said, from third to it might jump four, that means higher energy, five or else in the six, and whose spectral region is IR, infrared, right? IR region. And next passion to next bracket. So according to bracket, what he said, the lower energy level is fourth, and from fourth energy level to they can jump from 5 or 6, and whose region will be always spectral region is what, IR only. And finally P fund, whose lower energy level was 4, that means the lower energy of P fund series is fifth, and it might jump to 6, the only single way, and which is also comes under the IR spectral region. So dear student, this is all about today's class. If you are having any doubt, please do ask. Right? Thank you.